Now let us study some of the very important functions that we need to use frequently in solving the problems. So here is the first function, which we call as a constant function, and it is given by f of x equal to k, where k is a real number. So if you draw the graph of this particular function, it will look like a horizontal line, right? And the point on y-axis where it cuts, it is 0 comma k. So here if we see the domain of the function, and what is the meaning of domain? It is nothing but what values of x are allowed for this function. And if you see that x can have any real value, that is, for entire real number line, the value of x will be allowed to go in as an input to the function. So therefore the domain is nothing but the set of real numbers. All the real numbers are allowed here. And if we consider the range of the function, by the range we mean the value of f of x itself. What are the possible values of f of x here? Now here if we see that on the y-axis, the only value that the function attains is the value k, isn't it? There is no other value on y-axis for this particular graph. So therefore the range is nothing but a single value, which is k, right? So that is the domain and range of the constant function. Now let's go ahead and see the next function, which is linear function. Now here the function is given by f of x equal to ax plus b, where a and b are some real constants, right? Now as the name indicates, if we draw the graph of a function which has this particular definition, it will be nothing but a line. That's why it is called as a linear function, because we know that the equation y equal to ax plus b represents a straight line, right? Now here also, in general, if we consider the line as shown here, the domain will be nothing but set of all real numbers, and range will also be set of all real numbers, because it extends on both the directions on x and y axis. Let's go ahead and see the next function, which is a quadratic function. Now here the f of x is given by ax square plus bx plus c, where a, b and c are real numbers and a is not equal to 0. Alright. Now from the name it is clear that the expression for the function is a quadratic expression. Alright. Now if we want to draw the graph of this particular function, we have to consider two cases, that is a is positive and a is negative, right? Also further we have to consider the other factor, that for the quadratic expression we have the value of the discriminant, right? So if discriminant is less than 0, discriminant is equal to 0, and discriminant is greater than 0. Now based on this we'll have 3 possibilities. So in all we have total 6 possibilities of the graph. Now what happens if we consider the first case, that is a is positive and delta is negative? Now remember, whenever we have a positive, we will get the graph of the function as a parabola which opens upwards, right? So therefore the parabola opens upwards. Now if delta is negative, that means the discriminant of this particular quadratic expression is negative. It means that if we write f of x equal to 0, that is the quadratic expression equal to 0, since discriminant is negative, it will not have any real roots. So it will mean that the graph of the function does not intersect x-axis anywhere. So therefore it will look like this, right? It's a parabola opening upwards and it does not intersect x-axis. Now if we consider the next case, that is delta equal to 0. Now here if discriminant is 0, then we know that we get two real and equal roots. So therefore we have the graph touching the x-axis at one point. Alright. Now moving ahead, if we have delta as positive, we know that we will get two real and distinct roots. So therefore the graph will cut the x-axis at two distinct points. So therefore it will look something like this, where we have two different roots of the corresponding quadratic equation. Now if we consider the other possibility, that is if a, which is nothing but the leading coefficient as it is called, if it is negative, then we will have the parabolic graph but opening downwards. So therefore here we have the case now as if delta is negative, once again there are no real roots, so therefore the graph will be opening downwards and without intersecting the x-axis, right? If we consider the second case, that is delta is 0, then here the graph will touch the x-axis as shown here in a single point, right? And if you consider the last case, that is when we have delta positive, then it will mean that the graph intersects the x-axis in two different points, and therefore it will look like this. So in short, what we have to remember is the graph of a quadratic function is parabolic in shape, and based on the nature of the leading coefficient as well as the discriminant delta, will have these different possibilities, right? Now let's go ahead and see the next type of function, which is the polynomial function. Now the polynomial function is defined as f of x equal to a0 plus a1x plus a2x square plus so on up to an x raised to n, where all the coefficients denoted by ai, that is a0, a1, a2 and so on up to an, all these coefficients are real numbers, right? So that is what is called as the polynomial function. And of course it is also, we have to also keep in mind that the n is a natural number, right? So here the polynomial function can be of lot of types, because based on the variety here there can be countless polynomial functions, so therefore there is no single graph of it. So one of the example could be, say, a cubic function. There might be a cubic function whose graph looks like this, okay? And there can be all the possible varieties of polynomial functions of different degrees and different shapes, right? Let's see the next type of function, that is the rational function. So a rational function is nothing but a function of the form f of x equal to g of x upon h of x, where g and h are the polynomial functions themselves and h of x is not equal to 0 because it's in the denominator. So the rational function is nothing but one polynomial upon another polynomial, in simple words. It's called as rational maybe because of the analogy with the rational numbers, which we denote as p by q form. So therefore here it's a rational function. Now within a rational function there are two types, that is it can be either a proper rational function or improper rational function. Now by proper we mean that the degree of the numerator polynomial is less than degree of denominator polynomial, and the improper is the other possibility, that is degree of numerator is either greater than or equal to the degree of denominator. Now as an example, if you want to see the example of a proper rational function, okay, it means we have to have the degree of numerator less than degree of denominator. Alright, so therefore let us write one example here. Suppose we have x plus 1. It's taking a bit of a time to load. Okay, so x plus 1 whole divided by let's consider some polynomial which is of higher degree. So now the numerator is x plus 1, that means it is linear and hence it is degree 1. Right? So therefore in the denominator I can have something like, say, x square plus maybe say 2. So x square plus 2. Alright, that is the example of proper rational function. And improper is when we have, as we can imagine, the degree of numerator is either greater or equal to degree of denominator. So we may have something like, say, x cube minus here I wanted to write x cube minus, it could be, say, x just hold on for a moment, it's taking a bit time to refresh the screen. It's x minus, say, 7 whole divided by, so this is a cubic polynomial in the numerator, whole divided by, say, x plus maybe 1. Okay, so therefore x cube minus x minus 7 whole divided by x plus 1. That is the example of an improper rational function because the degree of numerator is greater than degree of denominator. Now many times what we have to do is, suppose we get improper rational function, then we have to convert it into the proper form by simply dividing the numerator by denominator. So we know how to divide two polynomials. Now on dividing, what happens is we get the quotient as some polynomial function and the other part, which is remainder upon divisor, that becomes a proper rational function automatically. Alright, so that is the requirement in many situations.